Greetings, class. The next subject matter that we're going to work on has to do with a procedure known as hypothesis testing. Now, that might sound kind of complicated or fancy, but it's really not that big a deal. In another segment after this one, I'm going to introduce the idea of hypothesis testing, or introduce the concept of hypotheses, I should say. And there are a couple of things that you need to keep in mind when it relates to formulating hypotheses, thinking about hypotheses. But we'll get that into the next. We'll get into that in the next clip. If you have a decent handle on the use of the t-table and a decent handle on the construction of confidence intervals and what those confidence intervals mean, then t-tests shouldn't be too much of a challenge, because in a sense t-tests are the inverse, in a way, of building confidence intervals. When you build confidence intervals, you took the t probability distribution and determined what two limits encompassed a certain portion of that distribution. So 80%, 90%, 95%, and so on. Right? So you built intervals, lower limit, upper limit, and those intervals encompassed a portion of the probability distribution, specifically 80%, 90%, 95%. With t-tests, it's a little bit different, because what you're going to do is, for the first time, calculate a t-value. So far, you have dealt with t-values, but those t-values have come from the t-table in the back of SPATs. If you need a refresher on using the t-table, or if you need a refresher on interpreting the t-table, there's a segment in the previous week's videos. But when you look at the t-table, as I mentioned in a previous segment, these middle numbers in the middle rectangle are all t-values. And as a refresher, those t-values are the amount of standard error that you could expect to occur given certain conditions, your sample size and your task at hand. All right? Again, those t-values in the middle are amounts of standard error. That's what t-scores are, standard error. On the t-table, those t-values in the middle are the amount of standard error you could expect to occur, the amount of standard error you could expect to surround a mean given certain conditions, and those conditions are your sample size or degrees of freedom and the task at hand. Now, so far, the task at hand has been the building of confidence intervals, but we're going to switch things up a little bit and determine and do different tasks, I should say. So in a sense, or not in a sense, in actuality, in order to conduct a t-test, here's generally what you're going to do. I know this is just introductory in nature. We're going to revisit all of this stuff shortly. But what you're going to do is draw the probability distribution. You're going to determine where the tails should be based on the space of the probability distribution that will be dictated by the table. And then you are going to determine where on this drawing your t-value falls. That's essentially what a t-test is going to involve, those steps. Now, I'm going to elaborate on those steps later on, but in essence, those steps are pretty much what a t-test entails, at least as far as the math goes. Drawing the probability distribution, deciding where the tail or tails should be, then calculating a t-value using your data, and then deciding, does that t-value fall somewhere inside these limits, or does the t-value fall outside the limits? And as a preamble, I will tell you that when your t-value falls inside the limits, somewhere inside the body of your distribution, the distribution that you drew based on certain information that we haven't worked with yet, you'll be given that information. When your t-value falls inside those limits, you have witnessed a relatively common event. There's nothing strange or unusual going on with your data if your t-value falls somewhere in here. If your t-value falls outside of those limits, so for example here or here, you have witnessed a rare or an uncommon or an unusual event with your data. Inside the limits, it's normative, normal, what you could expect to occur by chance alone. Outside the limits, it's not normal, it's not usual, it's not likely that what you observed occurred by chance. And so in a sense, t-values and hypothesis testing really represents our first, we've dealt with many statistics up to this point, but it's your first foray into probability testing. So in sum, what we're going to do is, in the next clip, talk about hypotheses and what those are, and how to set things up to test them, how to create the right conditions to test them. We're going to talk about hypotheses. But in essence, we're going to be doing largely the same thing you've been doing with confidence intervals. You've been drawing the probability distribution. You've been charting t-values from the t-table on that probability distribution. The t-values that encompass a certain area under the curve. The only difference, the only thing we're really adding, is the calculation of a t-value, a data, let's call it in fact this is exactly what I'll call it, a data generated t-value, and then determining where on this probability distribution your data generated t-value will fall. That's really the only thing we're adding. Everything that t-tests for one sample involve, you have worked with before. The only thing we're adding is the generation of a data generated t-value from your data, and then determining where on the probability distribution it falls.